Hello there and welcome to lesson 9.6, day 2, solving rational equations. In this lesson, we will solve rational equations that are not proportions. Previously, we solved rational equations that were proportions, in which we could cross-multiply to solve. Today, we'll need a different technique because we will solve rational equations that are not proportions. There are various techniques we could use. There are a couple. In my experience, I like to stick to teaching just one. Otherwise, some students tend to combine elements of both, giving them kind of an incorrect process. So I'm going to stick to one technique, and here is that technique. In terms of the big picture, we're going to solve these equations by canceling out the denominators, by multiplying by the LCD of the denominators. That's the big picture. Now, in terms of the details, we got to start by finding out what the LCD is. Then we're going to multiply it to all the fractions, both sides of the equation, and something magical will happen. Those denominators will cancel out, and we'll be left with an equation that doesn't have any fractions anymore. It might be a linear equation or maybe a quadratic equation. Whatever type of equation it is, we'll solve it, and we'll check for extraneous solutions just like we did previously in Chapter 9. Let's use this as an example. 2 over y plus 1 over 2 equals 5 over 2y. I must begin by identifying what the LCD is. Well, between y, 2, and 2y, the least common denominator would be 2y. In open disclosure, you wouldn't have to necessarily use the least common denominator. You could use 4y, you could use 12y, you could use 24y squared. You could use any common denominator. Okay, but you want to use the least to make it easier on yourselves. So now that I have my common denominator 2y, which is really kind of 2y over 1, I'm going to multiply it to both sides of this equation. I'm going to multiply it to this side over here and this side over here. And I'm writing it as 2y over 1 just to remind you that when we multiply to the denominators, we're really just multiplying by 1. So I'm not going to show that work because it doesn't really change anything. Really, just think about it as multiplying 2y to the tops. So when I do that, I'm going to have 4y over y plus 2y over 2 equals 10y over 2y. And right now, it doesn't look like we've made this equation any easier to solve. However, this is now where the magical part happens. Remember the big picture. These denominators are supposed to cancel out. Okay, and they will. I've got a y and a y that'll cancel out, leaving me with just 4. I've got a 2 and a 2 that'll cancel out, leaving me with just y. Over here, 10y over 2y, that reduces down to 5. So I went from having an equation with fractions in it to just a one-step linear equation. We subtract 4 from both sides. We determine that y is equal to 1. Checking it to see if it's extraneous, well, looking at my denominators, the only restricted value I see would be 0, and 0 is not the answer we got, so y equals 1 is a perfectly valid solution. That's a good example to start with, just to get the mechanics in the process. But that example did have just an easy linear equation for us to solve. Let's look at something that'll maybe be a little bit more interesting. Here, in a situation like this, think of x and 7 as being over 1. Might make it easier for you to find the common denominator if you do. So if my denominators are 1, x, and 1, my least common denominator will be x. So I'm going to multiply an x to the top of each of these. Remember, just to the tops. We can still keep the equation balanced because we're multiplying it to both sides. So x times x would be x squared, giving me x squared over 1. 12 times x is 12x, so I've got 12x over x. Okay, 7 times x is 7x. Now I have 7x over 1. These denominators should disappear. Let's see what happens. X squared over 1 is x squared. That's good. 12x over x would have those x's cancel out. And 7x over 1 is simply 7x. So our denominators do disappear. That's good. That's what we want to have happen. This time we don't have just a linear equation to solve. We have ourselves a quadratic. I know it's quadratic because my highest degree is 2. And to solve a quadratic, we've got a lot of options. The most popular ones would require us to get all the terms on the same side and solve maybe by factoring, using the quadratic formula. Okay, we've got a lot of options. I'm going to try factoring because when it works, it is the fastest, in my opinion. And there are factors of 12 that add up to -7. Those factors are -3 and -4. If you take both of those factors, set them equal to 0, and solve, you will get these two solutions, x equals 3 or x equals 4. Checking them to see if they're extraneous, well, the only restricted value I have would be 0 from that x under the 12, and we didn't get 0. Okay, now you could check to make sure you did your algebra correctly. Plug 3 in for x, see if it's a solution. Plug 4 in for x, see if it is a solution. They both will make that top equation work. Okay, so these are two solutions to this rational equation. That one was a little bit more challenging because we had a quadratic equation to solve. But let's look at something that makes more of a challenge at the beginning of the problem. So here, in this situation, finding the LCD is going to be more challenging. In order to identify the LCD in a situation like this, we've got to make sure we factor everything that is factorable. And right now I'm targeting that b squared minus 1. That is factorable. It would factor into b plus 1 times b minus 1. So looking at all three of my denominators now, b plus 1, b minus 1, and then b plus 1 times b minus 1, my least common denominator would be b plus 1 times b minus 1. So I'm now going to take that and multiply that to each of these fractions. And I'm going to give myself a lot of space to do that. Okay, I'm just trying to show my work here. So I'm exaggerating those fraction bars right now just to give myself room to show my work. So taking that LCD and multiplying it to all the tops now. Here I go. B plus 1, B minus 1. B plus 1, B minus 1. B plus 1, B minus 1. I just barely have enough room to sneak that in. Okay, remember the whole point of doing this is so that we can cancel out our denominators. So let's go down the line now and see if anything cancels out. Starting on the far left-hand side, I have common factors of b plus 1 in the top and bottom. And if I go ahead and distribute that 1 there, all I'll have is a b minus 1. In the second fraction now, I've got common factors of b minus 1 that cancel out. Again, if I distribute that 1, I'll just have b plus 1. All the way on the right-hand side, everything there cancels out, leaving us with just a 2. So finding the common denominator was more challenging here. We had to factor first. The rest of this shouldn't be too bad. Got a linear equation here. We combine like terms on the left-hand side. The -1 and the +1 will cancel out, but b plus b is 2b. So now I have 2b is equal to 2, and I divide by 2 on both sides to figure out that b is equal to 1. Checking to see if it's extraneous, I see a couple problems here. If b was equal to 1, then I'd have a 0 in that denominator and a 0 in that denominator. And I can't have that. So that tells me we have our first example of an extraneous solution here. And since the only solution we got was extraneous, that would indicate that there is actually no solution to the original equation we were trying to solve. So at this point, we've done 3 examples of varying degree of difficulty. First one, not too bad, just a linear equation to solve. Second one had a quadratic where we had to factor. This third example, we had to factor in order to identify the LCD, which made it a little bit more challenging. There are some interesting word problems that can be solved using rational equations, and I want to talk about the most popular type here. The most popular type of rational equation, word problem, would be a situation where 2 people or 2 machines or something are working together to perform a task. So I'm going to read it out loud. Mr. Nydeen and Mr. Erickson paint houses in the summer. Mr. Nydeen can paint a single-family home in 12 hours. Mr. Erickson can paint the same size home in 8 hours. We want to figure out how long it takes them to paint the house together. Okay, and I did use this as a warm-up in class. That's why you see warm-up on the top. Okay, but let's now talk about how to solve this by writing a rational equation. Here's the thought process. In order to figure out how long it takes them to paint this house together, we're going to take their rates. So I'm going to take Mr. Nydeen's rate, in other words, the speed at which he can paint one of these houses. I'm going to take Mr. Erickson's rate, how quickly it takes him to paint one of these houses. And since they're working together, I'm going to add their rates together. And that will give me what I sometimes call like the together rate, how long it takes them to paint one of these houses together. Let's fill in some algebraic expressions here, starting with Mr. Nydine's rate. We know it takes Mr. Nydine 12 hours to paint one of these houses. In other words, he can paint one house every 12 hours. Mr. Erickson can paint one house every 8 hours. We want to know how long it takes them to paint one house together. So there's the setup. There's the equation. Solving this is something we've already talked about in this lesson today. We need the least common denominator of all three of our denominators. 8 and 12 share a common multiple of 24. And since one of my denominators has a t, I need a t in my least common denominator. To save a little bit of space, I'm just going to multiply by 24t to the tops right here. And 1 times 24t is just 24t. That's why I can just, cover that up right there. And now we simplify. 24t divided by 12 would be 2t. 24t divided by 8 would be 3t. 24t divided by t would be 24. And we no longer have any denominators. We just combine 2t and 3t to get 5t. We then divide both sides by 5 to solve for t and get a final answer of 4.8 hours. It makes sense to get an answer less than 10 and less than 8, less than 12 and less than 8, sorry. Individually, it takes them 12 hours and 8 hours. So working together, it should be faster than 8 hours, and it is. It's 4.8 hours. So that's how we can solve this type of combined rate problem, by using a rational equation. So that right there was lesson 9.6, day 2, solving rational equations. Thank you for watching.